All right, so now we've got an instance of the IBM FHIR server up and running, and I'm going to take you through some of the options for loading data. So first up, we're going to do a simple create. So this is a post to the resource type of the endpoint you want to create. Here I'm passing an application FHIR JSON content type, and this is what the resource contents look like. So if I create this, by default, you'll get back no body with a 201 created and header values that include a location to this version that just got created of this resource. Note the server assigned long GUID plus timestamp prefix here. We also get back an E tag that we can use to check from the client to make sure kind of we have the most recent copy of the resource. All right, so now there's also an experimental feature that's defined in the specification called conditional create. We enable that by passing an if none exist header, and the value of this header is like a search syntax. So here we're saying if there does not exist a resource that has an identifier with system example.com and value 123, then we want you to go ahead and create this resource. Now note that that is exactly the system and value we have here. So if we go ahead and send that one, we'll get a precondition failed and an operation outcome response stating that this resource already existed, so we didn't create a new instance of it. Now, one of the limitations with the conditional create is that we do a search that's followed by a create, and there is a very small window of time there where competing threads could create a resource, and so you could end up with, in high volume scenarios, you could end up with multiple copies of this resource still. So for those higher volume workloads, we especially recommend our create on update behavior, and we have some special features that we've enabled here that make it real good for working at the, for doing ingestion as part of a pipeline. So some of our offerings have a kind of a pipeline that happened in front that then ends up loading a FHIR server, and we generally recommend those to use the create on update. So note we're doing a put to a patient with an ID of patient1. In this case, this is a variable, and the ID of the resource has to match. Other than that, it's exactly the same as the previous resource. And we're again passing application FHIR plus JSON. And let me just disable this one for now. So now we've created an instance of this resource, and now we're going to show a special feature. This is really supported out of HTTP, but it's not mentioned at all in the FHIR specification, but we've had a lot of users find this one useful. So if you don't want to override this resource if it already exists, so you want to say, do a conditional create on update, similar to that conditional create, only directly based on the ID. We can do this with high concurrency and guarantee no copies, no additional copies of the resource. And so if we do this, because that resource was already created, we get a if none match precondition failed. Now finally, we do have another feature here. By default in our 4.10.2 release, this is a client opt-in, so you actually have to enable this and pass this value. However, one option we're exploring is for future releases to actually make this the default behavior. And so currently, if the client opts into this and you perform an update on the resource, that update will only happen if it is a true update, so there's actually something changed. And so if I go ahead and do this, we'll actually see we get back version 6, no matter how many times we do it, unless there's an actual update to make. So let's say we change that ID here. Now it's revved to version 7. Okay, next up, we're going to show a patch. So the IBM FHIR server supports both JSON patch and FHIR path patch. This is an instance of a FHIR path patch. So this can be a really valuable operation if you're trying to just update one or two fields. Your client may not have the most recent version of the resource. You don't want to actually update any of the other fields accidentally. You really just want to send a message that says, please update this one field. So in this example, we're doing a FHIR path patch replace of the patient active. And so previously, if you recall, that was set to true, and we're patching it to be set to false. So we're basically saying, okay, this patient is no longer active. And you can see we're sending it to the same URL that we had put the resource. So we go ahead and look at that, and we'll see active is now set to false. All right, so finally, that gives you a flavor of kind of some of the options for sending data in. Obviously, just one resource at a time. However, it's more efficient, and also a lot of times you'll want a single transaction to submit a lot of resources all at once, and the FHIR server supports that through the batch/transaction endpoint that's defined in the specification. So in order to generate a lot of data, there's a really handy tool that we're going to use called Cynthia. So this is the synthetic synthetic patient generator. Now I've already cloned this locally and built it, but I'll kind of take you through what that would look like. So basically you get the project on your system, and then you can run a Gradle W compile Java. That'll just compile the classes without running any of the tests. They have a very large test suite, so if you compile and run the tests, which is good practice, just know that it might take a while. So once you've got that pulled, you can actually run the Cynthia project and generate a population. Here, this is generating a population of 100 people. The -O is just saying that that's like the total count of both alive and deceased patients. If you remove the -O, you'll get a few more than 100. Because some of those patients would be deceased. In this case, I think I'm actually gonna make sure I'm got a fresh output directory, because I think I have some in there still. So I'm gonna remove that, and now we're gonna run our Cynthia project. And for now, I'm just gonna generate 10, so it goes nice and fast here. All right, so this is gonna start up the synthetic health generator here, and then we should see it start to generate some patients in a minute here. Okay, so once that happens, we're going to go to that output directory, and the Cynthia data ends up being generated in kind of a few different files by default. So here we're using the default config. So we're going to get a transaction bundle for each patient. However, those transaction bundles are going to reference practitioners and organizations that represent their providers. And they actually end up using the same, a special feature that I haven't shown yet, which is called conditional references. So let's take a look at that now. Okay, so now you can see we've got our 10 transaction bundles generated, one per patient, and we also have these two files here. So these are the ones that define the actual providers that are referenced from all these transaction bundles. So we actually need to create these ones first. So let's do that through our Insomnia REST client. So here I'm going to just cat file to my buffer. I think it's like pb copy. Oop. Let's try it again. Output FHIR hospital. There we go. And then we're going to pipe that to our pb copy. So that'll put it on my clipboard, and from there I can paste it into my batch create. Okay. So this is that bundle. Again, this is a batch request, so that means that each entry within this bundle is going to be created set in a separate transaction. So you might have some succeed and some fail. In this case, I'd expect them all to succeed because this is a known good copy of Cynthia with valid resources that is generating. So within it, we'll have a number of, in this case, organizations and locations. Now, something that's interesting here is they do set this if none exists. So this is the same header field that I was setting previously on my conditional create. So you can see the Cynthia project is actually generating a batch request that's only going to be creating these resources if they don't already exist on the server. So let's go ahead and send that in. All right, so now we've got all of our hospitals created, and we'll do the same exercise for the practitioners. All right, so in this case, we have practitioner resources and we have practitioner role resources. And we're going to go ahead and submit that. Just like with the organizations and locations, these also are using that if none match header. And so this will only happen if they don't already exist on the system. So we've got all of those loaded. And now we should be able to do a transaction bundle of our resources themselves. So one way we could do is we could just actually use our same trick here. And then we could duplicate this request and do a transaction create. And let's see what this bundle looks like. All right, so we can see that this is a patient bundle instead of a batch. This is now a transaction. And within here, we are going to have these conditional reference values. So let me see if I can find one of those. So basically, wherever we have a reference to a practitioner, instead of actually specifying the resource ID of that practitioner, which FHIR would call like a literal reference, it's a reference to the literal resource ID of that practitioner. We have here what's called a conditional reference. So servers that support this, including ours, will actually perform this search as part of the transaction and replace the reference value here with the correct reference value for this particular practitioner on the server. So let's see if we can take a look at what that might look like. Let me grab the ID off of this one. Oh, actually, first let me see. Okay, so this is doing a put of an encounter with an ID. And it's actually doing a post. And so on a post, it's going to be a server assigned ID. So we actually need to grab the identifier if we want to check this particular one. All right, let me find that quick. Here it is. So this is the system and value. Actually, let me just grab the value because it looks like a UUID. So I think that'll be sufficient. Okay, so I'm going to try to create this one. Ooh. And we hit request entity too large. That's actually a default on the Nginx Ingress. It's only going to support up to 1 meg by default. It's possible to extend that, but instead let me just look for one that's a little shorter here. All right, so this looks like a much smaller thing here. All right. All right, and let me look for one of those references so we can show that it got resolved correctly. Oh, so here's one. So this is a encounter resource again, and it's referencing this particular practitioner. All right. So we're going to do that, create. All right, so we can see that was successful. So that means all the resources that were being submitted, and there's a lot of them, even though it's smaller than the other one, those have all passed our validation, and any conditional reference like this was properly resolved. Let's see if we can find this in the output here. So again, actually, we're looking for the identifier here. So this is an encounter with this identifier. So on the right-hand side, I think this is actually the second entry. So let's skip the first one. So we're expecting it to be this one here. With a batch create, you end up with an operation outcome that has kind of any warnings, informations, or error messages as part of an operation outcome. It's a little hard to see through there, so let's just do a search for this encounter resource. So we'll go here, look for an encounter that has an identifier of that value that we copied. All right, so we did get a result of 1, so this should be our encounter. Let me make that a little bigger, and we'll see if we can find, oh, shoot. Now, this is another feature. This is actually, I have this summary count. So this is actually only giving back the number of resources, not the actual values of those. Let me omit that, and we should get the resource itself back. And if we go through here, we should find a reference to our practitioner. And you can see that where that conditional reference was, it's been replaced. Actually, that's the patient itself. We want the practitioner one. Let's see if we can find that one. Here it is. Okay, so that one. So this should match what we had submitted before. So let's just dereference that just to be certain here. So we'll do a get of practitioner. This one. Oops, did twice. There we go. All right, so this is the identifier that should match from our transaction create. Which was that second one here. There. 97592. Great. Okay. So you can see this works okay for sending individual transaction bundles, but if you've got a whole bunch of these things that you need to upload, it's best to write a little program. But you don't have to do that because we've already done it for you. So we've got a project within our repository called FHIR bucket. So if we look at the README for this, it's got a lot of utilities for working with large amounts of data to, load test our server. It ends up being a real nice way to load a lot of data quickly if you don't have like infrastructure for a whole data pipeline. So recently we've added support, and this is yet to be in a release, but should be in our next release for driving standalone. And so traditionally we've used this tool to load from a cloud object storage bucket. So like it's an S3 compatible cloud storage system that's part of the IBM cloud, but really this code was written to work with any S3 compatible storage. So you load all the Cynthia data up there, and you can kind of load it real fast onto servers. But we did add recently support for something called immediate local, and so this will actually upload just from a local directory on your system to the server. All right, So hopefully this has been helpful. Next up in the series, I think I'm going to cover all the different ways you can get data out. So first I'm going to generate more data, put it into the server, and we'll catch you next time with a lot of the more advanced search features on the IBM FHIR server. Thanks.